Hi everyone, my name is Alexis Segoviano and I am in Group 1. My team members are Anaí Ramos, Priscila Rodriguez, April Todd, and Aileen Moriel. In this presentation, I will be going over our electrostatics lab where we explore how objects become charged and how those charges interact with other materials, whether they're neutral, grounded, or isolated. In our last lab, we saw attraction and repulsion between charged objects, but we didn't measure or we couldn't exactly explain why that was happening. In this lab, it being more of a quantitative experiment. We built on that by using an electrometer to measure the charge and test out different ways objects can become charged, whether it being through friction, conduction, or induction. We also made predictions for each part of the experiment and compared them to what we actually observed, which helped us understand electrostatics a little bit more clearly. So for our materials, in this experiment, we used an electrometer and a Faraday ice pail to measure charge. We used a banana plug patch cord as well as a pith ball. We also used a glass, acrylic, and a PVC rod, a fur, silk, and wool cloth, two mounted plastic spheres for experiment E, and photo. So for our procedure, before starting the experiment, the banana plug cord was used to connect the ground part of the electrometer to the Earth's ground. We grounded the electrometer and zeroed it to make sure it was ready to measure accurately. Next, we attached a piece of foil to the banana plug cord and let it dangle off the edge of the table. Then we charged the electric rod with each of the three clothes and tested it in the ice pail and recorded whether it was positive, negative, or neutral. The same for the glass and PVC rod were done. They were charged by each of the clothes and tested out in the ice pail and recorded their charges. Next, based on the results of Table 1, we chose to proceed with the acrylic rod and the fur cloth for the different parts of this week's experiment. So a prediction for part A was made and conducted by charging the acrylic rod by rubbing the rod with the fur cloth. Next, the charged acrylic rod was then brought into close contact with the dangling foil without touching it, and the results were recorded. A prediction for part B was made and conducted by charging the acrylic rod by the fur cloth as well. Next, the charged acrylic rod was then brought close to contact and touched the dangling foil, and then removed and then brought back together again. The results were recorded. Next, a prediction for part C was made and conducted by the charged acrylic rod by rubbing the rod with the fur cloth. The charged acrylic rod was then brought close contact with the pith ball but never touched the pith ball, and the results were recorded. Next, a prediction for part D was made and conducted by charging the acrylic rod by rubbing the rod with the fur cloth. Next, it was brought into close contact with the pith ball and touched it. Then it was removed and brought back together again. The results were recorded. For step 16, Part E, the two mounted spheres were placed together to into contact, touching, and then the acrylic rod was charged by rubbing the rod with the first club. Next, the acrylic rod was brought close to one of the spheres without touching and held in place for a few seconds, then removed. The two spheres were then separated and each one was tested with the electrometer and the ice cup to record the charge. So here you can see that the acrylic is being charged, then tested in the ice well as described, and we noticed a negative charge. Next you see is the glass being charged by the fur cloth. And when put in the ice well, we really didn't see any movement. It stayed neutral. Then for the PVC, it was charged as well by the fur cloth, put in the ice field, and we saw it go into a positive charge. Next we silk, and we really didn't see any change. It was neutral. And we did try different board trials to see if we did see a change, but throughout those trials we did see that it would just stay neutral, it wouldn't move to the negative side or positive side. Next we chose the acrylic rod, tested in the ice pot, and we saw a negative charge
Next slide.
on the
Okay,
electrometer.
okay. That was the.
So next we charged the PVC rod, and we saw a positive charge. So the same thing can be said for the silk. We charged the glass rod as we did many trials, and we really didn't see any change. It would stay neutral as well. Then we checked the PVC rod into charged it with the wool, and we saw positive charge. We charged the acrylic rod with the wool clothing, and we saw a negative charge.
It's like negative.
We tested, we tried charging in different ways, but we still saw that it did have like a negative charge. So here are our observations recorded into the table, and we saw that the acrylic rod would show more of a negative charge with the different pieces of cloth. The glass, we really didn't see any change. It was mostly stay at zero, so we recorded it as neutral. And for the PVC, we did see that in some cases it will go more to the positive side. So after doing these experiments, we went ahead and chose the acrylic rod with the fur clothing to complete the other experiments. So in part A, we predicted that the aluminum foil would be attracted to the charged acrylic rod even without touching. And in the video, we can see that our prediction was correct. The foil was attracted a bit to the rod, and we could see that the electrons in the foil caused it to shift, creating an induced charge. So for part B, that's where we touch the foil with the charged rod and we again predicted attraction. We did see that the foil was attracted, and this time the conduction occurred. The rod pulled the electrons from the foil, leaving it positively charged and causing attraction. So for part C, we brought the charged rod close to the pith ball without touching it. We predicted that we would see it like repulsion, but what we saw was attraction, and we can infer that this was due to induction. The charged rod shifted the electrons within the neutral pith ball, it being a one system compared to part A where it was grounded. This one was just one system. And it created opposite charges that pulled them together. So for part D, that's where we touched the pith ball with the charged rod. And we initially predicted repulsion as well. But in this case, we saw attraction. After looking or researching this, we noticed that this probably would have happened because the charge was either transferred from the rod to the ball, making both objects charge and causing them to stick together. So for part E, we demonstrated induction with two metal spheres. We brought the negatively charged rod near one of the spheres, and we predicted that this negative charge rod would cause a shift in electrons and make the sphere the one close in contact to the rod, more positively charged, and the negative charges would repel and move to the other sphere. After separating the spheres, one was measured positive, the one close in contact with the rod, and the other one was negative. This confirmed that induction can create opposite charges without direct contact. In conclusion, this lab allowed us and showed how charges are created by friction, transferred by conduction, and influenced without contact by induction as we saw in part E. We also saw that neutral objects are attracted to charged ones because charges can be rearranged within materials. The electrometer allows us to confirm the sign of charge throughout the experiment. Overall, our predictions did match most results, and this experiment gave us a deeper understanding of electric charges behave and interact. Thank you. And these are credits.